Okay, this is going to be over chapter 4, section 5, and then 4.6, which is equations with logs and exponents. Okay, suppose you have 4 to the x plus 1 equals 64. If you can make the bases the same, that's the easiest way to do these. In this case, 4 to the x plus 1 is equal to 4 to the third, so x plus 1 is equal to 3, and x is equal to 2. Now, in this case, we have 7 and 2 to the x minus 3 and 49. Always move whatever is farthest away from x first, so you divide by 7. Now you have 2 to the x minus 3 is equal to 7. You can't make these bases the same, so then we rewrite these with logarithms. So it's log base 2 of 7 equals x minus 3. Then you evaluate this on your calculator. Log of 7 divided by log of 2. Calculate that and then add 3 to it. When you calculate this, you should get about 2.8. Adding 3 gives you 5.8. Okay, suppose you have 2 to the x equals 5 to the x minus 1. In this case, I would put a log or ln on both sides. So I get ln on this side, ln on the right side. Then you can move your powers down in front because of the power rule. So it's x ln 2, x minus 1 ln 5. ln 2 is a decimal, so you convert that. ln 5 is a decimal, 1.609. Distribute that. Then we combine our x's. When you combine the x's, you get 0.916x is equal to 1.609. And then when you divide by 0.916, you get 1.757. Okay, ln, the base here is e. So you have e to the third is equal to 8x. Divide by 8. E to the third is 20, divided by 8 is 2.51. That should be that one. And you can check it, and it should work as long as make sure you don't put a negative into this logarithm. Okay, suppose you have ln of 2x plus 3 is ln of 4. We had that rule that if the ln's are the same, then your middle parts, 2x plus 3, has to equal 4. And subtract 3, divide by 2, you get a half. And again, check to make sure this isn't negative. Okay, this you're going to have to combine the logarithms. You'll get log of x divided by 3 because you have subtraction is equal to 2. Then this is a 10, so it's 10 squared is equal to x over 3. That's 100 equals x over 3, multiplied by 3, so x is 300. And you do need to check to make sure this answer, when you plug it back in, all the x's, is positive. And that's section 5. Now, section 6 has some applications in it. One example is the seismographic tables that they use, or in this case, this was Alaska 1964 earthquake. It registered this was on the Richter scale. I don't remember what the was in that particular one. This is same one. Sorry, it's a magnitude 9.2, and downtown dropped down. Now, examples of problems are find the half-life. If they give you this function here, half-life is when half of the material disappears. So in this case, your ending amount is half of your starting amount. So it's going to be 0.5 if your starting amount's 1. You can put any numbers in that you want. I use 1 and 0.5 because that's just easier numbers. Okay, then you have 0.5 is equal to e to the negative 0.028t. You want to solve for t. If you'll rewrite these as exponents, e is your base, so it's log base e. 0.5 is 28t. Type this in the calculator is 6931. Divide by 28, and you get 24.76 years. So whatever element this is going to take almost 25 years to deteriorate. Triplet investment, continuous compounding. Well, here's our formula we've used. It wants to triple it. So your ending amount and your starting amount, this is going to be 3 and 1, or any way you want to do it, 5 and 15, it doesn't matter. I use 3 and 1 because that's tripling it. And again, rewrite it, log base E 3.07t. Convert this into a decimal and divide by 0.07, and it's about 15.7 years. Okay, now they gave you a function that approximates the consumer price index. Consumer price index is about how much things are going to cost compared to different years or whatever. We want to find out when the cost is going to be 75% more than 1990. Well, if you have 100, 75% is 75% more than that, which is a 175. Okay, divide by 100. Then we're going to rewrite it. Log base E as an ln. 175 is equal to 0.26t. Take your calculator, type that in. Divide by 0.26. It turns out to be 21 and a half years. If the consumer price index started in 1990, 21 and a half years from that into the future is 2011. So that's how you work problems involving exponents and logarithms.